In this set of video notes, we're going to look at section 5.3, solving quadratic equations by graphing or factoring, and determining a quadratic function from its roots. So, quadratic functions and their zeros. We've talked about that before. When a soccer ball is kicked in the air, how long will it take the soccer ball to hit the ground? So in that scenario, we have a soccer ball, it gets kicked, and then it hits the ground. The height in feet of the ball after t seconds can be modeled by the quadratic function h of t equals negative 16t squared plus 32t. In this situation, the value of the function represents the height of the soccer ball, so the height at any particular point in time. When the ball hits the ground, the value of the function is 0. So when we're looking at the quadratic, when we find the zeros, the x-intercepts, the roots, all those fun words mean the same thing. So 0 of a function is the value of the input x that makes the output f of x equal to 0. The zeros of a function are the x-intercepts. We've talked about that. Unlike linear functions, which have no more than one zero, quadratic functions have two zeros. So we have 2 right here. These zeros are always symmetric about the axis of symmetry. So we have this axis of symmetry that folds in half, so it's symmetric on both sides. Let's look at an example. If we have function x squared minus 6x plus 8, we're going to find the zeros by using a graph or table. And what we're going to do is, in the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac over 2a. What we notice is that negative b over 2a has something added to it and subtracted from it. And that's because the negative b over 2a is where it is symmetric, because we're going same distance to the right and to the left. So we are going to use that to find the middle of our table. So we have a table of x and y values. And we're going to use x equals negative b over 2a to find our axis of symmetry. So we have negative b, which was negative 6, over 2 times a, which over here is 1. So if negative 6 becomes positive 6, 6 divided by 2 is 3. So the x value for axis of symmetry is at 3. So if we move 1 to the right, 4, 1 to the right, 5, and then we go backwards to 2, backwards to 1, then we can find out what the symmetric points are. So if I plug in 3 into my equation, 3 squared is 9, minus 3 times 6 is 18, plus 8. So 9 plus 8 is 17, minus 18 is negative 1, so we have a point here at 3, negative 1. And then if we plug in 2, 2 squared is 4, minus 6 times 2 is 12, plus 8. 8 plus 4 is 12, minus 12 is 0. And we know, since it's symmetric, that the 4 is at 0 as well. So we already found our two zeros. So let's graph those. So at 2, 0, and 4, 0, we have our parabola. We can do the same thing with b. So let's make our table of x and y values. And we want to find the center where the axis is symmetry. So let's do x equals negative b over 2a. And that would be negative b, which is here, negative 2, over 2 times a, which is negative 1. So negative 2 is a positive, so this becomes positive 2 over 2 times negative 1 is negative 2. So 2 over negative 2 is negative 1. That's in our middle. So if we plug in negative 1 squared is 1, so we have negative 1. Minus 2 times negative 1 is a plus 2, plus 3. 3 plus 2 is 5, minus 1 is 4. And then we can pick points to the right and left. So if we have -1, we add 1 and we get 0, and add 1 we get 1. Subtract 1 we get -2, subtract 1 we get -3. So to make it easy, I'm going to plug in 0. 0 squared is 0, minus 2 times 0 is 0, so we just have 3. And if I plug in +1, +1 squared is 1, and then we have a negative in front, so -1. -2 times 1 is -2, plus 3. -1 and -2 make -3, plus 3 is 0. So there's our 0. And since we have symmetry, this is also 3, and this is also 0. So our axis of symmetry is here at -1. And then if we plot the actual points for the graph, so that is a dashed line because it doesn't actually exist. -1, 4, and then 0, 3, and -2, 3, and 1, 0, and -3, 0. And there's our parabola. So let's look at the next page. And we have roots and factoring. We've talked about roots and zeros and x-intercepts and solutions. So you can also find zeros by using algebra. For example, to find the zeros of x squared plus 2x minus 3, you can set the equation equal to 0. The solutions to the related equation represent the zeros of the function. The solution to a quadratic equation of the form ax squared plus bx plus c equals 0 are roots. The roots of an equation are the values of the variable that make the equation true. You can find the roots or sum of some quadratic equations by factoring and applying the zero product property. So functions have zeros or x-intercepts. And equations have roots because we square root, fourth root, third root, or we solve, so they are solutions. Let's take a look at some of the examples. We have finding zeros by factoring, so we're going to find the zeros of the function. So in our first example, we have x squared minus 4x minus 12, and if we factor, we know that it's x times x is x squared, and then two things that multiply to get -12 that add to get -4. So 6 and 2 multiply to get 12. We know because they multiply to get a negative, one is positive, one is negative. So this means one's positive and one is negative. And then the middle number, negative, means the biggest one is negative. So negative minus 6 plus 2. And then if we were to find the zeros, we'd set that equal to 0. That means that x minus 6, we add 6 to both sides, we get x equals 6. And then x plus 2, we subtract 2 from both sides, we get x equals -2. In the next function, we have 3x squared plus 18x. They both have a 3 and an x in common. So if I divide 3x out of 3x squared, I just get x. And if I divide 18 by 3, I get 6. And I divide out the x, I just have x plus 6. And we set that equal to 0. That means that 3x can be 0, which means if I divide by 3, I get x equals 0. Or x plus 6 equals 0, minus 6, x equals -6. In letter C, we can factor x times x is x squared and -6. We know that it's a positive times a negative because this makes a negative when we multiply. And we know that the biggest one is a negative. So -6 times +1. Because 6 times 1 is 6, negative times a positive is a negative, and also -6 plus 1 equals -5. So we set that equal to 0. X minus 6 equals 0, add 6, x equals 6. And we set x plus 1 equal to 0, -1, x equals -1. So those are our two answers. If we look at letter D, they both have an x in common, so if I factor out an x times x is x squared, and -8 times x equals -8x. And we set that equal to 0. So x equals 0, and we set the other factor x minus 8 equal to 0. Add 8, and x equals 8. And that was the basics of roots and factoring, and take a look at part 2 to look at projectiles and solving.